My new power supply is really small, but I like that it still has a large screen, and the best thing about it is that it's actually easy to operate. So unlike a lot of these smaller power supplies, I find this one to be usable without having to read the instruction manual, at least for basic tasks. As you can see, there's the set values are in this box here, and then the actual values are in yellow here. And you can move that cursor around up and down using these, then just rotating here. I don't think there's any acceleration on here, which is a good thing. So what I'm going to do is just set this at 5 volts for now. Go back down to 5 volts. Okay, and then yeah, you can just turn it on and off here. And you can also set like over voltage and over current protection as well. I've set them to kind of semi-sensible values. Okay, and what I've got here is the oscilloscope just set to trigger. I just want to see what the output looks like when you turn the output on. So if I turn that on, that looks pretty good. That's 50 milliseconds per division. So it does take quite a while to ramp up, but there's no like spikes or anything like that. So what I'm going to do now is just go up to maybe 12 volts and redo that. Yeah, still looks good. Try 20 volts. Oh, that one is on. Okay, so I've turned it off. Turn it on. Yeah, still looks great. And then try something much lower. So let's go to 1 volt. So it looks like the minimum is 10 millivolts. Okay. And off, and now on. Yeah, it looks good. Let me just increase the volts per division on that. And redo that. Off, on. Okay, and now I'm going to try and capture the off. To do that, I need to change the trigger. So you go to menu, trigger, and I want a negative trigger on channel 1. All right, and so at the moment it's the output's at 1 volt on here, so I can turn that off, and I'm going to have to adjust the time base on here. Okay, that's on, and that's off. So it does take quite a while, but obviously that's because there's no load on the device. Here's a test under load. I've set it to 5 volts, and the load is a 1 amp load which is being switched on and off 10 times a second. So I'm using a programmable load here, and that's configured for 10 hertz. And what I've got is a current clamp, not a very good one, but it's good enough for this exercise. And you can see in the green there the 10 hertz switching of the current. So the current is switching between 0 amps and 1 amp there. And the yellow trace is showing the voltage. So that's what I was interested in looking at, to see what change in voltage there is as the current increases and falls. And there's really not much to it. So you can see the 5 volt level there, and there is a slight change there, but it's very insignificant, I think. Here's another load test. Now I've set it to 12 volts, and I've set my electronic load to switch on and off at 100 times a second, a 2 amp load. So that's pretty extreme now. And you can see in the green trace there, it's switching between 2 amps and 0 amps. That's at 100 hertz. And again, the yellow trace, so if I hit that, you can now see on the scale 12 volts. And again, there's a very slight change in the voltage and a little dip there as the load increases to 2 amps. But that's very insignificant. And in a real life scenario, you'd probably have some bulk capacitance on the input of the circuit. This is a test to see how quickly the power supply can switch from constant voltage to constant current mode. I've set the power supply to 12 volts there, and a maximum current of 300 milliamps. And I've got an electronic load switching every second, it's trying to switch on a 2 amp load. So you can see there in the green that the output is 2 amps, and then it drops down to about 300 milliamps. And there you can see the amount of time it takes. It takes under 10 milliseconds to achieve that. But the interesting thing is, if I now increase that value 0.3 amps to say 0.8 amps, you can see that the time it takes is extended out to beyond 10 milliseconds. And I can go all the way up to say 1.9. Oh, that's at 1.8 amps, and you can see it's now taking all the way beyond 80 milliseconds to drop from 2 amps down to about 1.8 amps. The waviness is an artifact of the current clamp. It's just not a very good current clamp. Here's the same test, but now set to 3 volts, and again at 300 milliamps you can see that the load went from 2 amps down to 300 milliamps in under 10 milliseconds, and then as I increase that, so about 1.5 amps, and there it's now taking about 30 milliseconds, just under that, to drop from 2 amps to 1.5 amps. What that means in practice is that, say if you know that your circuit should not consume more than 1 amps, then you should try and set this value to very close to that value, so 1.1 amps for instance. Connected, and I'm looking at the power supply 5 volt output with the AC coupling. That's there in yellow, so it's 10 millivolts per division, and here's a spectrum from 100 hertz all the way to 10 megahertz, and that's actually looking really good. Here I've got some measurements. The M measurements are low pass filtered to a 2 megahertz bandwidth, and you can see there that the RMS noise, AC RMS noise, is about 100 microvolts within that 2 megahertz bandwidth, which is about 1.2. So yeah, the maximum is about 1.5 volts peak to peak noise within that 2 megahertz bandwidth. The power supply has a load of other features as well, which I've not tried so far. For instance, it's got chart capability for either current or voltage, as I understand. Yeah, there's voltage now. I've not really experimented with that much. And also, it does have a RS-232 as well as a USB interface at the back. So it's possible to program the supply. Overall, I'm really pleased with this power supply. I'm just relieved it's got a actually usable user interface. I've not looked at the user manual so far, and I was able to control things. It's fairly intuitive, and I was also very happy that turning the power on and off doesn't seem to cause any unusual glitches or anything like that. Well, I hope this short video was useful. Thanks for watching.